and then he can decide how to handle that failure. Across nodes, if a whole node goes down on one cluster, you get a whole bunch of these errors pop up, and you have to figure out how to reconstitute that entire portion of your search tree or whatever was on that cluster. The beauty of Akka is you design this from a single-threaded perspective, and then when you hit clustering, it's not that much different to restore. Okay? All right, so with clustered actor systems, we're now taking that topology and we're partitioning it on our nodes. We're figuring out which pieces to throw where and how we want to fragment out our program. You want to limit the instances of things using routers. So if I don't want to start something on every node in the cluster, right, I can limit it by using that clustered router aware stuff and say, I only want 3 instances in the cluster. That's the max I'll ever need, kind of thing. We can register with other nodes and actors and things using cluster listeners. Everything I do in the cluster needs to be reactive. A new node came in, a new leader was elected, this node went down. Everything I do has to react to what's happening in the cluster. I don't make assumptions or think I can go read the state. I just react to what happens. Okay? We use roles to fragment actors across the cluster. That's a new one that I didn't really have time to dig into. But essentially, you can take your cluster and partition parts of it for roles where, this subcomponent exists in this portion of the cluster. Okay? And then we can keep singleton actors on either a leader or on a role leader. The role leader is just within a set of nodes with a role. He's the leader for them. Okay? But it's the same concept that we saw before. There's role leader election that happens at the same time as leader election.